I think all the boards and all the stuff we've seen so far has been kind of interesting. You know, there's been quite a few things to look at here. But I think that the most interesting stuff is going to be inside the actual projector itself. And basically, yeah, that's it right there. I guess we can say that excluding the lamp, you know, because the lamp goes in here, excluding that, you basically the whole projector is this this whole unit like right here. So inside here is where we're going to see the board that interfaces to the DLP chip, and the DLP chip is going to be right here. This aluminum casing right here, that's going to be where a lot of the optics are, and we can see that there's like a cylindrical structure here. So that right there is going to be where the light, you know, travels. There's probably going to be some lenses and stuff in there. Looks like right here we've got there's probably going to be a mirror, and then that goes upwards like that and out the lens. Something that I think is kind of interesting here is that they've used this sort of shroud right here, and it's got this cutout as if, you know, it's to kind of like match the image output and prevent like any stray light, you know, from hitting the lens or coming out of the lens or whatever. This easily comes off. It's just got these sort of little clips right here on the side. We'll take that off in a minute here. But other stuff that's here, right behind where I'm assuming it's going to be some sort of a mirror here, there's a little board, and there's a tiny little 4-position ribbon that goes down into it. So I don't know what's going to be in there, but hopefully that's something interesting. And here we have, there's sort of like this little block right here. So there's going to be stuff in there because there's a wire coming into here, like this really thin. It's actually a set of 3 cables that comes into this area here. So I'm kind of curious to see what that's going to be also. We have our large fan here for cooling the fan. That is the board for the lamp, to power the lamp here. We're going to take that off and take a pretty good look at it there. So that's pretty much everything we're going to be looking at here. There's a little board here with a little button, and what that is basically when it's got the cover in place back here, there's like a little interlock switch right there. So there's a little peg that pushes up against that switch and activates it so that, you know, the set knows that this is closed and it's able to operate. One thing that I noticed, and I don't know when this was done, so these 2 wires go to that board. That comes down to the board right here. Look what's back there. It's a little jumper. So I don't know if the little switch up here at some point went bad, and instead of replacing it or trying to fix it, somebody just jumped the terminals. So there it is. So just out of curiosity, we're going to hook up the multimeter. We're going to remove this jumper, hook up the multimeter, and poke on that switch and see if it even works at all, because that is just crazy. And I just happened to notice that when I was looking at it. I'm like, wait a minute, why is that there? And sure enough, goes up to that switch. So basically, I think that this thing could operate all the time, even if it doesn't have that back cover on the lamp. Which, yeah, it's not ideal, and you really would not want to do that. And then one other thing we're going to do before we close up the video is we're going to take the DLP once we actually look at its internals, and we're going to compare it to these other 2 sets. This here is an LCD, this here is an LCOS, and you know, we could do these 2 and those 2. We have, you know, 4 total projection units here, but we're going to do -1 back there because that one's just a CRT projector, and there's not a whole lot to see on that one. Or -1. We're just going to do these 3 right here, compare these 3 because these are, you know, fairly similar technologies. That one there is just a CRT with a big lens in the front. And, you know, as far as the CRT projector goes, you know, there would have been 3 of these. The red, green, and blue. This one here's the red tube. And basically, that's all it is. It's just the CRT on the back. It has a fluid in here that, you know, keeps the actual screen kind of cool. And it also acts as like an optical sort of a coupling between the actual CRT and the projection lens here. And then that's where you get your projected image, bounces off the back mirror and onto the screen. So that's all there is to that. And you can see it's a CRT for sure. There's so like back here, you know, in this neck, that's where like the filament is and all the stuff that kind of controls the beam. We've got some coils back here And that's about it, and our high voltage connection. So that's it. If we remove the shroud that was on top of the lens there, we can see that it's actually also being used not only to, you know, just provide like a certain window there for the light to come out of that lens, but it also locks the lens into place. If you look down here, like to the left of my finger there, you see like there's a little tiny tab to the left, and actually there's one on the right as well right there. You can see it. And that, what that does is it locks this lens here. It locks the adjustment. So I'm pretty sure that this here is the focus for the lens there. We can see that this lens is like really rounded, so it's very convex. And so this is on the DLP unit. On this LCD unit, this lens has a kind of a dimpled shape. You can see that it kind of comes up right in the center. There's a dimple, and you know, and then it goes back out. I am not an expert on projection lenses, you know, so I have no idea what this is actually called. I'm probably gonna have to look it up. But I think basically what this is doing is it's making the light spread, like, you know, wider than it would be otherwise. And this type of lens here actually looks very similar to the ones used on the back of a LCD TV, the LEDs for the backlight. You know, they take that light, and it's not very bright in the center, but the light gets spread out, you know, like out the sides quite a bit. So this could be, you know, the type of lens that you want to use if you want to have like a really short throw between the actual projected image or the projection, you know, like source, and then the actual screen itself. One thing about all these TVs is that they were all like pretty much generally about the same size. So it's kind of funky that they, you know, this one here has this like big round convex lens, and this one here has this sort of like dimpled lens. Yeah, I'm gonna have to look up the name. I'll see if I can even find it. I'm not sure what that's called. And this one here, this Elcos one, it actually has what looks like a convex lens on the inside, but then it's got this other lens over the top that's clamped down with a few screws here, and these sort of like little tabs. But the final lens itself is actually extremely flat, as you can see. It's also very dusty. But yeah, that's it's been sitting for a while. Another thing I had mentioned earlier about how the remote receiver board, you know, kind of sat off to the side of here. I don't remember if it was left or right, but anyways, it sat kind of here like near the lens, so that when you would point your remote at the TV, you know, it could pick up your signal from, it doesn't matter where you point at it. There wasn't like a special little like infrared window where you had to like kind of point it to receive, you know, like power on and channel change, whatever. All these here had the similar kind of setup. This is the receiver for the remote on this one, and this was mounted somewhere in the chassis, like, you know, somewhere inside there like that, kind of pointing at the lens also. I don't remember exactly where this one was, but that's the board for this TV. And this is the front panel. As you can see, we have all the buttons there and all the status LEDs, but there is no infrared receiver. So that's because this was also mounted inside. So it's basically using the whole screen as the remote receiver. And on this one back here, this little structure here, that's where the infrared receiver is. So this also, you know, basically used the whole screen as the infrared receiver for the remote. Another thing that you will pretty much always see with any of these projection TVs other than the CRT ones is that they have cooling fans, because the lamps get very, very hot. So this one here has a big cooling fan just for the lamp itself, but then we've got a small cooling fan in the back for the DLP chip itself, or what I'm pretty sure, you know, is going to be for the DLP chip right there. So this Toshiba DLP has the 1 and the 2 fans, so you know, that's it. On the other hand, this LCD one, check it out. We got 1, 2, 3. This was mounted up in a like a big shroud up here that kind of guided air like around this whole area here. So that's 3, 4, and I don't remember. I think there was another one somewhere inside there. When we open it up, we'll see. So that would be a total of like 5 fans just in this projection unit alone. The lamp is actually over here off in this box off to the side. You can see the lamp's right there. It flashes in here, it goes through all this stuff and out the projection lens. On this Alcos one here, we have 1, 2, And down here inside, we can see like a fairly, if I can get the light in there, we can see that there's a fairly large blower in there. So that's 3. I don't know if there's any others hidden anywhere in here. I guess we'll find out when we open this up a little bit. Actually, we can remove this stuff here because it's already sort of removed. Yeah, I can't exactly tell at the moment. So that's 3 that we can like see right off the bat. So not as many as the LCD one, but certainly more than the DLP. Okay, I've undone all the fasteners. There was a screw and then like a bunch of little standoffs with the clips here that held this board in place. And I've also removed the connector that goes to the actual lamp here. We can see that the material here, like here, you know, it's fairly smooth, the side that wasn't facing the inside of the lamp, because the way this plugs in is this sits in there. When the lamp comes in, it slides into that connector like that. So it's kind of hard to see there, but on the inside here, there is a cutout where light can still kind of reflect off the inside of there and shine onto that. So as we can see, the light output from these lamps is fairly damaging, and this stuff here has gotten kind of like chalky and rough. So yeah, it's definitely affected the material there, and you can see some of it down here too. So it's all discolored and it's rough and very coarse now. So anyways, this will now come out, and yeah, it's pretty much all there is to it. We can see that this little board right here, this little control board, basically there's like slots that have been routed out from this main board down here on the bottom, and then all the contacts are kind of like soldered on the sides there. They're not all used. We can see that there's some right here that aren't really connected to anything, but you know, then there's traces going to the ones that are. The input right here, as we saw, there was like the high voltage side, like this right here, and that basically goes through all this stuff right here, that all the switching and everything. There's a full bridge rectifier down there, a big transistor right here, or MOSFET. I'm not sure what they're using on here. I have to look up that number. Maybe it's a MOSFET. And then down here looks like a couple diodes right there. One of that, we can see that they've used big beefy traces, and they've kind of left some of the mask off right there to kind of fill in with that solder. So they want, you know, pretty good amount of current going through all this stuff here. Looks like the switching here from this transistor, MOSFET, whatever, goes to this big coil here. That goes off here, and then it kind of goes in here. So maybe they're kind of using this as a power supply for this section over here as well. Kind of like a buck or something. Alright, so no, it looks like it is a buck converter here, but it's actually going to power the lamp itself. So all this stuff right here looks like it's just a bunch of resistors to kind of lower the voltage here for feedback for the control circuitry here, because there's a couple of jumpers right here that after that inductor, they go to here, a couple jumpers, they jump to here, they go through this whole other section here. These two right here are a couple of really large diodes, and you can see that they're right there covered up with some insulating material. I guess this board must be made by Rubicon, because it says Rubicon Corporation up here. So I guess it's not surprising to see that there's actual Rubicon caps up here also. So yeah, here's the lamp terminals right there. This little section here where it's got this inductor looking thing, that actually looks like a small transformer, and I'm going to guess that that's actually a high voltage like trigger to try to get the lamp to fire, because a lot of these like sort of small HID lamps, they only run at like about 80 some volts or something like that, but they need a really high startup voltage like to get it to fire. And once it does, you know, the voltage to maintain it powered up is it's a lot lower. And so I think that's what that little section there's doing, because there's some diodes and some caps right here. So it looks like that might be like part of a voltage multiplier sort of setup there. There's another small inductor up here. And that's pretty much it for all this. Over here where the interlock switch connects to, you can see that plugs into there. There's another set of 4 conductors here, so that looks like it comes from like one of the control boards or whatever. There's an optocoupler right here, so maybe power comes into here, the switch, you know, activates to let this know that it can operate, And if, you know, this doesn't, there's nothing here, you know, it probably doesn't let this board do its thing. So this whole section here is just completely isolated. And that's those two connectors right there. So I removed the screw that holds the little switchboard in place up here. So let's hook it up to our meter, and I'm going to push on that button there and see if we get any sort of response, or if this button here is dead or what. Alright, so I removed the little jumper they use there, and I'm just going to hold this right here. You can see we've got the meter set to continuity there, and it's going to measure low resist. It's basically just limited to 300 ohms. Alright, so I'm just going to kind of hold the two probes here on this connector here, and I'm going to push on it now, and let's see what happens. Oh yeah, that switch is extremely touchy. So I'm just holding it like pressure down right there. I'm not moving it, and it's like jumping all over the place. Now it's not making contact at all. So this button here, or this switch, definitely, or was it the probes? Let's see. I'm not sure now. Okay, maybe not. Maybe it was just the probes that I didn't have on there properly. As it turns out, apparently there's nothing wrong with that switch for the interlock for the lamp there. So what I did here is I just reinstalled the board where it's supposed to go. I got the probes here on the connector that would go to the ballast board there, and I've got some pretty good pressure on it now. Apparently the whole thing was that I didn't have much pressure when I was originally testing it out, and so that's why we were getting kind of like a shoddy connection there. But then I thought, okay, so maybe is there something wrong with the interlock here? This little pin here is the one that pushes on that switch. So I'm thinking, okay, maybe at some point, you know, this got damaged or something and just wasn't making very good contact against that switch, and it wasn't pushing it in. So let's see what happens here. And if I put this on, it's working just fine. So, and I'm kind of moving the probes here a little bit so the resistance is kind of jumping. But as we can see, once it closes, it's it's just fine. So yeah, no problems here with this door. So I honestly have no idea why anybody would have done that. Maybe they were working on this, got lazy, and decided to just leave this open and just jump this, and then they just never removed it. Remember, I mentioned earlier on in this video that there wasn't really any like darkening on any of the boards that I could really notice, except for maybe on this little ballast board here. Well, this is what I was talking about. You can see that in this area here, the board is just a little bit darker than the rest of the material. So that means that this area here would have gotten a lot warmer than like other stuff surrounding it, to the point where it discolors the material. This here actually turns out to be a MOSFET. It's a 600 volt 12 amp MOSFET. It's a 2SK2699 made by Toshiba. So the reason why this little area here would have gotten dark is because of these components right here getting fairly warm. And this whole area here, including like this right here, going down to here to the MOSFET, that's all the gate driver for that MOSFET. So the switching stuff going on around here, and it, you know, having to switch this on and off so fast and possibly generating heat in this area is what would have caused that to discolor a bit. The MOSFET is actually not driven directly by the control circuitry over here. It's basically isolated through this transformer. So everything from that side of the circuit here, from this source to the gate, and then the drain kind of goes off in this direction. I think that's the one that actually gets the power. So all this stuff right here is what turns the gate on and off through that transformer. And you can see that there's nothing here popular, so there's nothing linking this side to this side other than the transformer itself. And then this here is our controller board. So this would be our little microcontroller here. This is probably another op amp, and this may be a driver of sorts. I'm not sure. I have to look up that number. We see we've got 3 opto isolators right here. 2 are wired where the LED side is on this side, and this one here is wired where the LED side is on here. So these look like they would be inputs going to the microcontrollers. So maybe we'd have like our, you know, like turn on signal, we'd have our brightness signal, I don't know which one would be which here. And then we'd have a third one here that could be like an output for lamp status, so that the rest of the circuitry knows, you know, what's going on with this area of the TV, like if the lamp's working or not. Because we do have that lamp indicator up in the front, but this here doesn't connect directly to that. This would go off to the other microcontroller. The other microcontroller would, you know, figure out what to do with that information and display whether, you know, the lamp is bad or not. So basically like everything in this area here is isolated from this area here through means of these opto isolators, because there's no pins or anything going down to that side. I mean, there's that there, but that's not connected to any of this here. I couldn't find any information with the numbers on here, but I'm pretty sure that this is just a little microcontroller. That is an op amp. That is a 6358N. It looks like it's a Sanyo part, but it is an op amp. And then this here is a PWM controller. So this would be basically what's controlling, you know, like everything else on here. There's another chip in the back here, and that is an LM2904, and that's another little op amp. So that's pretty much everything on this board. I'm going to have to apologize to you guys. I was about to remove the whole projection assembly here, but I removed the screws here, and there's a couple in the back there, but my screwdriver will not reach inside to those screws, so I think we're going to have to end the video here. And unfortunately, we're not going to be able to see anything inside of that. No, I'm just kidding. I do have a really long Phillips here that will comfortably reach the screws that are way down there, and we can get those out and see what is inside of the projector. I had you go in there for a minute, didn't I? No? Okay. Okay, so it looks like first of all I had to remove this plastic shroud here around the lamp assembly, because it kind of blocks this from coming out, and this is screwed into the projector assembly there. And I guess I could have used a really stubby screwdriver inside of here to get these out, but it's okay. We're just gonna pull this stuff off here, and I mean, nothing special in here. That's just a fan, a 12 volt 6.5 watt fan, really nice and smooth. So it's a Sunon fan in there. It's a pretty decent looking fan. So now that I've already removed the screw here, actually it's not even completely loose yet. Thought it was. Okay, there it is. This should just lift off. Oh, there's some conductive tape up here in the front. It's like this metallized tape there, so they want some pretty good grounding between this chassis and the rest of the assembly. So there we go. Uh-oh, I hear something rattling around in there. That's not good. Oh, it's a screw that I left in here. Okay. So that's the whole projector right there. Let's look inside of it. This whole base here for that goes inside the main chassis here, it's like really rigid, because you don't want your image getting all distorted or something from, you know, like everything flopping around. So this is, it's fairly thick. Not sure what gauge that actually is, but it's maybe 12 there, but yeah, it's fairly thick and it is fairly sturdy. If we look inside this opening here, we can see right through it, and there is our color wheel. There's actually a window here, but it's using like some of that anti-glare glass. So to me, I mean, on the camera you can kind of see a reflection there, but if you're actually looking at this, it almost looks like you can just like see straight through it, and you can't see that there's any glass there at all. So it's really clear stuff. You can see that there is a, if it would focus here, that there is a metal retainer right here held on by that screw. So that kind of holds that little window in place there. I'm going to remove these screws here, and let's see if it reveals anything else. I actually don't think that will, because that looks like it's all just part of this aluminum assembly here, or magnesium or something. That up there, that's our thermal cutoff, so in case the lamp gets way too hot, you know, this would shut it down. And the biggest reason why the lamp would get so hot is probably if the fan becomes like too blocked, there's not enough airflow. Because other than that, the fan should keep it pretty cool. The board that's here actually is the one that controls the fan. The fan plugs into here, or, oh, right here, L fan. So the lamp fan. They've got some little designations right here as to what goes connected to these. So that says L fan there. There is a... Okay, so there's all the connections here. We got CW. Not sure what CW means. L fan, that would be the lamp fan. BS. Don't remember what that went to. Oh, maybe ballast, I think. PS. I forgot what went there. Or maybe that's power supply. Not sure. DB. DB went to one of these right here. It was, I think, yeah, it was this little 3-pin connector here. That's the one that goes somewhere in here into this the block there. And then we have SP. So SP goes to that board back here. Sorry, it's all blurry right now. We'll get a better look at it in a bit. So that's all that. There's a 2-pin connector here that's not connected to anything. There's another 2-pin connector here that wasn't connected to anything. So I'm not sure what those go to. On the opposite side, we also have our other connectors. That was our main interface here for our video. We have another little 2-pin connector here. Then this one right here doesn't have a label on it, but I think that was for, I think it went somewhere on the digital board. I don't remember exactly. Then we have another one here. This one says D fan. So this is for obviously cooling the DLP. That's the fan right here in the back. There was another one here that says B fan. I'm not sure what B is for. And then the last one on here that says power. So that would be power for the board inside of this case here. Man, I honestly don't even know where to start here, but I figured maybe we could just start off by taking off the lens assembly here for the actual output. And they had these screws coated with some sort of adhesive. So they put something on there before they close everything up here. As you can see, when I twist it, it cracks and all this crystal and stuff goes flying everywhere. So they didn't want anybody really taking these off. And of course, we're probably going to throw off alignment and stuff on this a little bit just by taking it apart. But it's not like I have to put this TV back together or anything, so it doesn't really matter. So we're just going to remove all 3 of these, and now this looks like it's fairly free. And it's coming off. Okay, I should probably undo this connector here. It's not going to come straight out. Okay. And whoa, we can see the little DLP chip right in there. You can see it all, it's all the way at the end. First time I ever seen one of those in real life. So here's the whole projection assembly. And that is our input there. So you can see that it's really nice and clean up inside here. So there's really not a whole lot of dust getting inside of this whole assembly there. So yeah, that's where this basically picks up all the light coming from the DMD chip right there through here up into there. And wow, it's pretty cool. Let's see what's inside of this box here. Looks like we should just be able to pop this out. Doesn't look like there's any screws or anything. So that one comes off there. This one should release here. Okay, that's just a cover for all this stuff here. And what have we here? Another little board. There's that 3-conductor cable that was going off to the main controller up there. Got some shielding here. A little 2-conductor ribbon here, but it's actually 4. It's actually 4 conductors on the connector, but there's only 2 going off to here. So they've got like 2 and 2 working together, and that just kind of goes off into there. We've got some screws we can remove, and oh, this is magnetic. Look, it's a fairly strong magnet too, because it just pulls this in like pretty hard. So that must be some sort of actuator, maybe like a an iris or something for like brightness control. I'm not sure. So let's remove a couple screws there and see what's on the opposite side. Okay, those screws are off. Now let's see if this just comes right out. And there it is. Oh wow, check that out. So it's this moves up and down. So yeah, it looks like it is some sort of a like a control for light. You can tell where the light's been hitting it from this side because it's all discolored. So yeah, these lamps are bright. So this would, you know, kind of maybe lift up to allow a little bit less light through. That's pretty cool. Alright, so there's 3 wires going to the connector here in the back, and you can tell that one's positive, one's negative, and then the third one would be like the actual signal going to. I don't know what kind of signal they're actually using, but basically what this is doing is it just controls like the up and down motion of this right here. There are some optical sensors that you can see right inside of there, and then there's a tiny, well, you can't really see it from here, but you might be able to see it sort of moving there. Inside that there's a little bit of the plate there with a tiny slot. I don't know if it's got like little slits or anything on it, but you know, that kind of moves around, so maybe that's just to indicate, you know, when it's reached the stop up here. This is spring loaded. There's a little tiny spring in there, so if I hold this upside down, you see that it will not go down, and if I put it down, you know, it'll spring itself back up. But I thought we could see it in action if I just apply a small voltage to the input here of this, because this looks like it just goes directly into the coil, so I shouldn't damage anything, I don't think. And I don't really want to damage anything on this if at all possible, because I kind of have a plan for some of this stuff, maybe to use it in the future. So let's see how much this thing moves here. I'm just going to take a 6-volt pack here. I don't think this should be too much. So let's see, I'm going to touch one to here. I'm going to touch the positive to here. Let's see if that does anything. Okay, that looks like it might be backwards. So it looks like positive needs to be applied to this one, and maybe a negative to this one, and there it goes. So, okay, that might be hitting a little hard. You know, once this thing actually controls it, it probably, you know, like is able to control how much it pulses the thing. But yeah, if I apply positive here, we see up motion. So that's basically how that works. I think we might be able to remove these screws here and maybe take a look at what's actually inside of that. I mean, it's going to be a coil and a pretty strong magnet. It actually almost seems like a voice coil from like a hard drive or something in there. But let's take a little bit closer look at it if we can. All right, all the screws are loose now, and I hope nothing comes through. Hanging out. Never mind. Okay, that was a little more violent than I was hoping it would be. But there is some neodymium magnets in here. There's one on this side, and I'm guessing they must be like oriented so that they're, you know, same poles on the poles like say north and north are like facing each other, because as you can see, yeah, they are really strong magnets, and it just kind of sprung open on me, but there it is. So this here is the coil that kind of goes around this assembly here. I don't think this will pull out now. So there's a little slit I was talking about right there. You can see it if I kind of point it to here. So there's the slit, and that kind of goes over these sensors there. So it's not, yeah, it doesn't have any like cutouts or like, you know, like little slits or anything. So it's not gauging its like position, or it's not like measuring, you know, its angle or anything like that. So it looks like it's just, it has like a stop here and then a stop here. So it just knows like where the two extremes are. So this looks like it may be, you know, just like either fully on or fully off thing. Like there's no like in between or anything like that. Through the magic of macro lenses, we can get a better look here at the coil inside there that activates that little shutter, or whatever it is. Maybe it's an iris or something of sorts. So anyways, we got the 2 wires coming off of here. You kind of go around to here, like around that sort of the center bearing there. They solder onto the ribbon, and then that ribbon comes around, goes around, and out to our connector here, 4-pin connector. So You can see that we've got a few ICs here. No idea what that actually is off the top of my head. So basically this is all the control stuff on this board here. If we look at the bottom side, there, that right there, that's that optical sensor, and you see that that slot there doesn't have any slits in it at all or whatever. There's another chip down there that would be the driver for the output here. We got some other stuff here, L324, so that looks like it's another op amp there. LM or L324, another one there. Some pots, little tiny trim pots right there. A couple screws, a kind of a power resistor there, it looks like, or maybe it's like a poly fuse or something. No, it says R74, so that's a resistor apparently. So that's pretty much it on this board. A couple of some test points there, test points, another test point. So quite a bit of stuff packed into this little package there just for controlling this thing. Right here at the top, you see that there's a little, like where it retreats to, there's a little bit of a bump stop there, so it doesn't hit hard. However, on the other side, it doesn't have anything. So this thing, like if it, you know, if it's like bottoming out, it just smacks up against that bottom portion there, and you can see how the coil just kind of rides on that. It doesn't touch it, but it just kind of glides along that center plate there. On that cover plate where the neodymium magnet is on this side that I took off, you can see how they have these sort of like little bumps there to just kind of align the magnet, and then it's just glued down with some adhesive there. There's a couple little bumps right there. There's one, oh, if I can stop the thing from reflecting so much, there's a bump there to kind of land on that side. Doesn't look like there's one here on this side, so it looks like what happens is they just kind of put it in there and align it, you know, to these three, and then it's you know, after they put some adhesive on the back there, they just kind of set it down and push it up against that, and that's it. So now let's take off this back piece here and see what that actually is. I'm thinking it might be a light sensor of sorts, but let's see. I don't think I need to take that off actually. Let's remove these screws here. Oh wow, these were way longer than I was expecting. Okay, let's see what's on the other side. Whoa, what is that? I mean, it's definitely a mirror. It's a surface mirror. You can see it's fairly reflective on the surface there. But I'm guessing all the magic is going to be behind it. I'm just going to set it aside here for now. But here we can see that we can look straight through to the other side of that lens there, the projection lens, and then that's where the light comes in. So light comes in through here, and you can see my finger being magnified there, and it's opposite of where my hand goes, as you can see. So it flips the image and then reflects off of that mirror, and then it gets projected out in that direction. I'm not going to take this whole assembly here apart, because basically it's just a bunch of lenses in here, and that's, you know, that's all there is. And there's not going to be, I mean, other than seeing like a bunch of lenses, there's not really a whole lot of stuff to look at. I know some people are probably like, you know, like lens fanatics or whatever, but I really don't want to damage anything. As I said, that I kind of might be using this thing for something else later on, so I really would like to minimize damage as much as possible. But we can see, you know, basically that's all it is there. We can see at this assembly here that they really want to keep dust out, so they have this sort of like foam surround all around the inside here, so that when this is attached to the back of that, you're really not getting any like dust ingress or anything coming up inside of there. So they want to try to keep this as clean as possible, and now I've kind of you know, messed that up because I've opened it up. But let's just put this back here so I can open this up and take a look inside without actually damaging that mirror. Alright, well, I realized that if I put those screws back, I wasn't going to be able to remove this rear plate here. So basically what I did is I just put this whole base back into the lens assembly here. And now I should be able to pop this off somehow, I think. I might have to get a blade in there in that edge or something and try to pop it out. Alright, that took a little bit more prying than I was hoping it would. But that's because there's a little bit of adhesive right here on the board and up against this plate here, so that was kind of stopping it from moving. But now It's lifting, and can't see much in there yet. Being very gentle. I don't want to damage whatever's in there. Actually, I see a coil in there. Oh, I think I know what they're doing. Let's see. Let's try to get the other side here off. I'm using a very dull blade. It's an old used blade and it's very dull, so I'm not too worried about cutting myself or anything. If I could get this side to pop out. I mean, it's sort of moving, but I also don't want to cut that ribbon there. Okay. Trying to be gentle. I don't want to, if I feel any force or something holding it down, I don't want to force it out. I still can't see anything. Okay, it looks like this ribbon here has been glued down in there, and I can't pull up on this side because of that ribbon, and I don't want to damage it. So let me see if I can maybe break apart some of that adhesive there first, and then I'll try to lift up the rest of it. Alright, turns out that's not going to be completely necessary because I was able to just kind of get it to come up a little bit here. But if we look inside, and I pull this up towards the front here, so I'm not damaging that ribbon, what we can see is there's a sponge in here. We also have another foam pad here surrounding this to kind of keep dust out. There is another coil in here, and that whole assembly there with the mirror is basically mounted. If I could kind of move this to the side here, so you can see it a bit better, like that. This is where the mirror is mounted. Actually, now that I think about it, I can just pull this whole thing off. It's fine. So, mirror is mounted on a couple of little pivots there, like that. So it looks like this whole magnetic assembly, this is a magnet over here. It's another neodymium magnet. It's another pretty strong one, and it looks like we're getting little bits of debris in there. Let's not do that. So, see the magnet right in there? There's a little slot. That coil there fits in that slot. So it looks like what this is doing is some very, very slight adjustments. I mean, because you're not going to need a whole lot of like adjustment to be able to, you know, like tilt that image at all. So this is like doing like very, very, very tiny bit of adjustment to that mirror to I guess I really don't know which adjustment that would be. That would be maybe like the keystone or something. So, and I don't know if this is all automatic or if it's something that, you know, that's done in the settings. So if it was, I probably just you know, decalibrated everything. But that's not a big deal. So yeah, that's what's inside of that thing. So I thought it was going to be just like some light sensor or something, but nope, it's another mechanical assembly. So this little board that's mounted on the back here, I removed the screw, and basically that's what it is there. This is going to be the driver for that. It's a TCA0372DW, and then a little chip here. I have a feeling it's probably going to be another op amp. It's the OP07C. So that's yeah, that's what's going on there. They're using the plate down here on the bottom as a heatsink for that chip. So if we look at this mirror assembly up close here, we can see that even though it's very rigid and those mountings there are really thick, you can still tilt it tiny amount. So yeah, this early in like the projection stage, any small amount of movement in this mirror is going to cause, like, you know, a much significant change in the actual projected image. I've reattached the mirror assembly here to the back of the whole projection lens assembly unit here. One thing that I would probably think is that these screws that held it here, these were probably originally like torqued down to a certain amount, you know, for screws. So what I did is that I used a very precise amount of torque on these screws, and that precise amount is just, you know, hand tight. Okay, so, you know, we had some foam there to kind of prevent dust from, like, you know, getting into this part here. But the funny part is that where this other assembly was here, there was no such thing. So dust can easily get into this part here, but then there's like another like lens over in this area here that, you know, would kind of block light. So basically there's no dust getting into this area of the projection lens here, but over here I guess they thought it doesn't matter much. So yeah, nothing there. Alright, so now let's look inside of the DLP housing and this whole assembly here. I just realized what CW is over here. That's the color wheel. So these 4 conductors here, they go to the motor that drives the color wheel. We'll see that in a minute here. And it's going to be like a really, really tiny color wheel based on, you know, the size of this thing right here. So it's only going to be about like this big. You can, you know, see part of it right there. And then this other one here, this other connector here that goes to PS, that's probably going to be a photo sensor, because this thing needs to know, you know, what section of the color wheel it's actually on to be able to switch the mirrors inside of the DMD, you know, to reflect the appropriate color output. It's funny, this whole thing's just sitting kind of there. Kind of reminds me of a Briggs & Stratton motor just because of the way it's made. Here we've got this like this sort of like rubber gasket to protect against dust coming into where the lens assembly attaches to right there. And it's kind of not that visible here, but you can kind of see where there's like a bit of a dark ring around here where there's like no dust, but then there's like dust a little bit on the outside of it. Okay, so looks like we need to remove some screws here from this cover, and that will allow this part to come off, and we can see the color wheel inside of there because there's nothing else here or here. So basically everything looks like it should be accessed from the front here. There are some screws inside of there that hold this backboard in place, so I think we're gonna have to remove those before we can actually look in. Although actually it looks like these screws here, if they come off, we can remove this plate from the back and we can take a look at that. So maybe we'll do that part first. Yeah, let's remove these and we'll look at this board. Okay, I removed the screws and I pried up on this a little bit and it looks like it's coming off. Something holding it over in this side. Oh, it's still some. Oh, maybe. Okay, maybe it's not going to come off until we actually. Oh, no, there it goes, there it goes. Okay. Alright, so there is the fan that cools off the big heatsink there, and there we go. Our first signs of DLP hardware. Got a big DLP chip right there, so this would most likely be the actual interface controlling the, or basically like the whole, you know, ASIC that controls the actual DMD in there, because the DMD itself is just basically the display device. There's another little chip right here that says DLP. Not sure, that looks like it might be like a power management chip or something. We got a few inductors here, like a bunch of caps. So that, yeah, definitely looks like it's doing something with power. Although over here on this side, looks like we got more power stuff. There's a bunch of inductors. We got a total of like 7 just in that little area alone right there. These 2 chips right here that say they're made by Thine, these are going to be like LVDS interface chips. So what they're probably doing is they're taking all the LVDS signals and probably splitting it up into individual like color, you know, chunks of color like data. So all the individual like color bits and all that stuff right there. A little bit of dust on its heatsink. We got a couple of spring-loaded screws right there, as you can see by looking at the side of it there. So it looks a lot, you know, like this would be like a CPU or something. We got a flash ROM over on this side here. A little, looks like a transformer right here of sorts. I guess maybe we can start by taking these screws off of the board here, and we'll remove the 2 from the heatsink and see what we can see from here. I'm not sure exactly how the DLP chip is interfaced to the rest of this board, but I guess we'll find out. Okay, I've undone the screws from here, and this heatsink is a little bit free to move now. Okay, there it goes. It just popped off. So now I lift this up, and that is the back of the DMD itself right there. So let's see. The opposite side of the heatsink there, we have our thermal interface material, and it looks like some of it kind of tore off a little bit here. Something really interesting that I noticed here. Look what they're doing. They have the screw there. There's a spring on this side. There's a spring in the middle right here. So it looks like what they've got going on is they have like 2 springs to hold like a certain amount of pressure on the heatsink, you know, to push up on that chip. Looks like what they do is they bottom the screw out all the way, and then basically the springs just kind of take care of holding the correct amount of pressure on the
on the chip itself. So I mean, unless you like really torqued it down hard, as long as you put it down as far as it'll go, it's gonna have the right amount of pressure there. And this is all, you can see that there's all the machining marks there. So basically, this was probably like quite a bit thicker, and then they just machined it to form that little block that goes through the board and contacts the chip itself in there. Looks like we got a little bit of a dust bunny in there. Couldn't get rid of them all, I guess. A little bit more dust kind of in there. So looks like maybe there might be some contacts here, like touching against that chip. So I'll remove these screws here and try to pull this board off and see what's going on inside of that. Okay, all those screws are out. Let's see, this board looks like it's moving fairly freely, so okay, and the DLP chip is apparently coming along with it. So, oh wow, that's pretty cool. It's mounted on a zip socket. I wasn't expecting that, to be honest. And holy monkey, we're gonna have to get a real good close-up of that. That is really neat. Like I said, I've never actually seen one of these for myself. So wow, that's pretty cool. We'll get the macro here and we'll look at this area here a little bit closer. On the side where the DLP chip is, we see we've got some like shielding right here. Some of this like sort of like spongy conductive shielding. We have a little bit of dust kind of on the outside of that. There is the window that the light kind of shines in and then reflects outwards. You can like see out through that lens there. There's like this big sort of prism assembly there. We'll get a good look at it once we remove some of this cover stuff on this side here. But yeah, so a lot of neat stuff. One thing we're probably not going to be, I don't know if you're going to be able to see it here on the lens there, but the way this prism is shaped, they have when the light comes into here, it goes through the color wheel. It looks like it comes off in this direction, reflects up onto that prism. The prism makes the light kind of come out this way to reflect off of the DMD, and then once it does that, then the DMD just goes straight out through the front there. Okay, got the macro. For some reason, it looks like we got a lot of skewing going on the sides there. I don't know why. Weird. Let me zoom in. Well, I think it's as good as it's going to get there, but there is the micro mirror device. So tons and tons of tiny little mirrors on that chip there. I'm going to unlock it and we're going to pull it off and see what's kind of a socket they're using there. And so yeah, basically this is it almost looks like a CPU of sorts. All right, chip is unlocked. Let's gently pull it off of here. And it's like a PGA, and that is the other side of it right there. And we can see that there's quite a bit of dust in there as well. So, wow. I guess it looks like by that sort of like heat spreader that they're using back there, it pumps out quite a bit of heat. So all that motion going back and forth is certainly generating quite a bit of heat there. There's the socket itself, and you can see how they have these sort of like cutouts here that match up with those molded like forms right here. So yeah, you can't, even though that it looks like it's got about the same amount of pins on both sides, because of this, that's it doesn't allow you to just plug it in however you want. I'm guessing that must be the part number there, 1910-6103W. I'm wondering if the W like stands for wide. So supposedly this is a 1080p capable TV, so I'm guessing the whole micro mirror assembly there should be like 1920 by 1080 like pixels. If you can count them, you're free to do so. There you go. That's probably as good as it's going to get. It might be hard to see, but the actual chip itself is not exposed. There is a window on top of it there. I'm trying to get this thing to kind of be in focus there, but the mirrors themselves sit below that window, and then this window looks like it's like epoxied to the surface there, you can see that there's some material right here. This whole metal assembly here looks like it's just for, you know, providing structural support. You can see that it's very thick, and maybe also some heat dissipation, but it is really, really thick, and you can see the substrate there kind of underneath that. This here, that's the layer of that, this sort of plasticky material there. So there's a much better close-up of all the pins. So these are not spring-loaded. These are just solid pins that go into the holes in that socket. And that's pretty much all we have to look at here. As I was saying earlier, these thine chips right here, basically what they're doing is they're taking the LVDS data and they're converting it to like RGB, like separate, you know, like bits. Supposedly this is doing like 14-bit color processing in here, so I'm not sure exactly where those 14 bits are being processed, if they're being processed on this board or on the other board or whatever. But anyway, there's this other chip here, and that's looks like it's a RAM chip there. It says MT on the bottom there, so it'd be like Micron Tech, and then, you know, everything kind of goes on in there, but everything kind of runs on the inner planes of this board, because there's really nothing like that you can see exposed on here other than like a bunch of grounds and like the odd large trace like there and there. You can tell that this is definitely a power IC by the amount of grounding right here, right in the middle of it. And yeah, like I said, the inductors and all that stuff, and then all this stuff around here, so that would be like another, like a power controller IC there. And that's basically, yeah, everything that's on here. On this board here, actually I just noticed that there's a slight bit of discoloration here from all the heat, and that right there is basically, you know, like this whole little power supply here. So this whole little power supply is very compact, but it does pump out a lot of heat based on the discoloration that we can see there. So it looks like all this stuff here, it looks like it's voltages for the digital micromirror device here. So, you know, that's looks like it might take a lot of power to get that thing, those mirrors, like, you know, vibrating back and forth so fast to generate your image. Alright, moving on. So I've already undone the screws from this lid here, and I thought it was one, you know, entire sort of lid here, but it's not. It's actually two separate ones. There's some tape here that kind of covers up some of this stuff here, but yeah, we can see that there's more than one plate here, so this should come off. And a lot of this stuff is like pretty tight fit, so it's kind of hard to pull on the sides there, but oh, there we go. There is the color wheel, and we can see a little tiny heat sink right here, so that looks like it might be for the driver for the color wheel. I'm not entirely sure, or maybe not. Kind of hard to see, but you see this little bundle of wires here kind of comes down, goes to the bottom there. Let's see if maybe you can zoom in a bit here. Let's get some better lighting. There we go. So there is the motor. There is the color wheel. You can see it rotating. See right there, there's like a black spot, so that'd probably be like indexing, you know, so that the rest of the system knows where in its rotation the color wheel actually is. And it's hard to see, but those are all the separate little color filters there. If I shine a light from the other, well, no, you're not gonna be able to see it because it's like the little windows on that side there. But let's see what else we got there. Got some another little lens assembly. Maybe if we remove this plate here, we'll be able to see that better. There we go. So, looks like there might be a mirror down here, because the path the light travels goes something like this. So in the back here, there's a, well, these cables weren't in the way. So there's that little window right there. Light goes through the color wheel, and then it goes into, there's like another sort of like a little tube right here, or maybe this is to cool down like that little, it looks like almost like a little light pipe in here. So it might be to cool that down. Light goes through here, there's something here that's like spring-loaded, and it looks like there's an adjustment here. I probably should not touch that if I don't want to like tweak anything. But then it goes through this other lens assembly here. Looks like it goes into that in here. So then the light would just kind of go off straight into here. And yeah, actually, if I can kind of see it from here, it looks like it's another surface mirror in there. So then that will light the bounce up through this lens. And then that's where this whole other prism assembly that I was talking about is. You can see it right there. So it's got like multiple facets, and it looks like it might be more than, sorry there, I'm trying to get it. Looks like it actually might be more than one, and they are bonded together where you can see these sort of like little circles like right there. So it looks like this is one prism assembly. It's angled, and then the other one just kind of interfaces to the face of that. So that's what I'm guessing. I'm not entirely sure, because you can see that the top one there, that this one right here actually looks bigger than the one down here on the bottom. So it looks like the light comes up through that lens down here, goes into that prism. Prism acts as a mirror, bounces the light to the back over here where the micro mirror device is, and then once the light reflects off of that, it just basically, this is almost like a glass, and it just goes straight on through. The top there looks like it's frosted, so there's really nothing going on there. And then it looks like they've got some sort of ribbing here, maybe to kind of disperse some of that light so that it doesn't affect anything, like it doesn't reflect back or whatever. So that looks like that's all that's going on there. Like I said, I'm kind of hesitant to remove any of this stuff here, just because it looks like it's got some sort of adjustment there, and it is spring-loaded. So I don't know. What we can easily do though is I can remove the motor here and this, and I mean there's not really much precision to this whole motor assembly or anything, so it's not like it's a big deal if I remove it. But that right there is the color wheel, and you can see how as I move it around, the filters like seem to reflect like different lights, but really it's just if I get it just right, you can see that it's just red, green, and blue. So as this rotates, the mirrors there take turns flickering, or they either reflect light or they block light, reflect or block, depending on what color they need to be. So this is rotating extremely fast, and those mirrors are they're doing the same. So if they say they needed to reflect white light, then they would probably just like completely stay on, so that they're just reflecting all the time. That way you have your red, green, blue, red, green, blue, just reflecting the whole time. If it just needed to be blue, they would only reflect when the blue filter comes into view, or red, or green, or if it's a mixture of the two, then it needs to be like reflect when it's green and red, but then block it when it doesn't need blue, or anything in between. It just basically, they're just going back and forth really fast to try to get the light just right. And the motor here, basically it's like a brushless motor, like something you would find like in a hard drive or something, or even in a quadcopter nowadays, or something like that. They've mounted it on a small rubber mount right here, so this isn't screwed directly. Well, I mean, these screws actually do go directly into this metal plate here, but this whole rubber like sort of boot right there, it kind of comes through these holes. So this whole thing is sort of like shock mounted, so that vibrations and stuff like that are not going to break this wheel, because as you can see, it's really, really thin glass, and I'm trying to be careful here not to drop it either, because I don't want to break it. So then at the bottom there, we can see that's that little board there, and there is our little light sensor there. So every time the black goes through there, the system knows that it's let's see, what color is that? That it's on green. So we have blue, green, and then red here. So as soon as it goes to that black spot there, I think the window is actually, the window's up here, so it looks like that's the index for green. So it looks, like green, and then I'm not sure which color it turns. I'm assuming it would turn like clockwise, so like green, and then blue, and then red, green, blue, and then red, green, blue, and then it just, just kind of goes around like that. Alright, we're not going to take off that little light pipe, like as I mentioned, because it looks like it's been like finally adjusted and stuff, so I don't really want to mess with it too much. But if we look straight down into that window where the lamp is, And since we don't have the color filter or the color wheel there, you know, you can just like see straight through it there. We can see it's rectangular shaped, and what that's doing is I have my finger here on the opposite side of where the DMD would be. So because of its rectangular shape there, what they're doing is they're shaping the light hitting the micro mirror into a rectangular shape that kind of matches the mirror itself. So they're only getting light to the chip itself, and it's not like spreading all over the place, so it's very concentrated in just that one little spot. So as I move my finger across the area where the micro mirror would be, you can see my finger there, and it's kind of hard to hold still just because the slightest amount of movement makes it go off focus here. But yeah, so you can see that there. So that basically is where the image would be formed, and then it just get reflected out of the front. So that rectangular prism that's in that little spot there that we looked at through the window, basically the light comes in from here, from the lamp. It goes through the color wheel, which would be like here, and then it just goes through that little rectangular prism, which then just like shapes the light so that the light that hits the micro mirror is basically the same shape as the light coming out of here. So that way we don't really have like too much wasted light. Like say, you know, it's not like a big round bunch of light just kind of there like reflecting off of that mirror. So that way it just concentrates the light to the actual surface of the mirrors. We sort of look at this how the way it would normally be assembled with the projection lens assembly and everything. We can see that it's pretty simple in how the light kind of comes in here, goes through the color wheel, through that light pipe. It sort of gets formed by these like lenses in here, and then it gets reflected up into here, and then that, you know, bounces off the mirrors, out the front, and through the whole projection lens assembly. So the fact that there's not a bunch of stuff that the light has to go through, you know, kind of keeps these DLP systems kind of simple. Now this is a single DLP system, but there are some that have 3, and you know that would obviously get a little bit more complicated because it's got to split the beam into like 3 separate colors. But because it's just the one, and because everything's like happening so fast, then you know there's really not a whole lot that's needed to be able to project an image out of this. And we'll quickly, I'm not gonna like do a whole teardown on those because it's gonna prolong this video even longer. It's already getting super long as is, and I've been working on this for almost like on and off like close to 2 weeks now, and I just don't want to prolong it too much longer. So yeah, we're gonna sort of compare, you know, how the optics are kind of similar and dissimilar from here to like say the LCD and the LCOS one. LCOS stands for liquid crystal on silicon, and that one works similar to DLP, but it's also, you know, partially like liquid crystal. So that's it's kind of like not entirely a hybrid of the two, but sort of. So I'll just briefly show you guys that one. But yeah, so everything's pretty much compact in a DLP projector like this, just because of the fact that you don't have to use like a bunch of optics in like the light engine to, you know, before you form your image and project it outwards.